There is a structure standing in the desert beyond Cairo that, by every objective standard, should not exist, not in some metaphorical sense. It should not exist when treated as a problem of physics, mathematics, and time. About 2.3 million blocks of stone form an artificial mountain that once rose 481 feet. Most of the blocks weigh between 2 and 15 tons. In some places, they fit so tightly that even a sheet of paper cannot pass through the joint. For nearly 4,000 years, this was the tallest structure ever created by human hands. Nothing else on Earth reached that height throughout that entire span of time. Yet its size is not the hardest part to explain. In 2024, Grok AI was presented with a simple question: who built the pyramids? It was not asked for the polite answer or the familiar line found in textbooks. The system was instructed to examine every recorded measurement, survey, geological scan, astronomical alignment, and engineering tolerance associated with the Great Pyramid of Khufu. The instruction had only two parts: analyze the evidence without allegiance to any existing theory. Report only what the numbers reveal. The result did not produce a name. It did not produce a date either. Grok began with the explanation accepted for more than a century, then tested each part of it against the measurements of the structure itself. The system had no theory of its own to defend. It could suffer no loss of reputation if the result challenged accepted belief. It simply placed the numbers beside one another. And once those numbers were laid out, the question of who built the pyramid began to divide into two different questions: who organized the quarrying, transport, and placement of 2.3 million stone blocks, and who possessed the knowledge required to make that immense mass conform to tolerances almost invisible to the naked eye. Before examining the numbers that gave Grok pause, we must first set out the complete conventional account. Around 2560 BC, during the 4th dynasty of ancient Egypt, Pharaoh Khufu ordered the construction of a tomb on the Giza plateau. The monument was completed in about 20 years. Tens of thousands of workers were organized into specialized crews. They were not columns of beaten slaves, as movies so often suggest. Most were skilled craftspeople: haulers, quarry workers, surveyors, bakers, brewers, and support teams serving the entire site. Limestone was quarried directly from the plateau. Finer stone arrived by way of the Nile. Granite for the interior chambers came from Aswan, hundreds of miles south of Giza. Blocks were loaded onto wooden sledges. Workers wet the sand ahead of them to reduce friction. Ropes, ramps, levers, and human strength carried the stones upward, course by course. Their stoneworking tools included copper chisels, stone hammers, and wooden mallets. Surveying was performed with knotted ropes, plumb lines, wooden squares, and shallow water-filled channels used to establish a level plain. These tools belong to the age of Khufu. Evidence of the workforce also remains at Giza. Archaeologists have uncovered a workers' settlement on the plateau, complete with housing, bread ovens, brewing areas, cattle bones, and the remains of a food supply system large enough to sustain thousands of people. Some workers' skeletons show signs of severe injury. Many fractures had healed. The injured were not abandoned. They received treatment, were given time to recover, and survived their accidents. Beyond the settlement, administrative records written in ink on papyrus document stone transport, labor numbers, and shipments moving along the Nile. One famous record describes the daily work of a crew carrying limestone to the construction site of Khufu. The scribe was not recording a legend. He noted the time, the route, and the work completed each day. Inside the pyramid are quarry marks, tool marks, and the names of labor crews painted in red ochre on blocks placed where no visitor was ever meant to see them. One crew called itself the Friends of Khufu. The name of Khufu appears in sealed spaces deep within the structure. These inscriptions were not placed at the entrance as propaganda for a crowd. They lie between blocks and inside chambers that served only the construction process. Layer after layer of evidence points to an ancient Egyptian building site. There was a king who commissioned it. There was a workforce. There were workers' homes, food supplies, transport records, and tool marks. There are even names belonging to the crews that hauled the stone. Human fingerprints cover the Giza plateau. The conventional explanation did not emerge from an empty space. It was assembled from stone, bone, papyrus, red ink, and everything that remained in the sand after more than 4,500 years. When we ask who organized the site, supplied the labor, and brought millions of blocks to their present location, the chain of evidence leads to the reign of Khufu. Grok did not discard that chain. It preserved every link. Egyptians quarried the stone. Egyptians transported it. Egyptians lived at the site. Egyptians left their names inside the monument. But that evidence answers only the question of labor. It tells us who dragged the blocks across the desert. It tells us who supplied the bread, beer, cattle, and housing. It tells us how thousands of people were organized around a single project for many years. It does not yet explain how a base more than 755 feet long on each side varies in elevation by little more than 3/4 of an inch. It does not explain how all four sides were aligned with the cardinal directions to within only a few minutes of arc. It does not explain why the relationship between height and perimeter appears to contain pi. Nor does it explain why the golden ratio appears repeatedly within the same structure. Archaeological evidence identifies the hands present at the site. The measurements begin to raise questions about the knowledge that directed those hands. Grok began at the lowest part of the structure, not in the chambers, not with granite blocks weighing dozens of tons, not with pi, phi, or any theory of a vanished civilization. It began with the ground. The first question was simply this: is the base of the Great Pyramid level? Each side extends more than 755 feet. The total area covers roughly 13 acres, enough space for several football fields. This surface was not poured from a single material. It was formed on natural bedrock, then cut, leveled, and prepared to receive millions of stones. Across the entire foundation, the difference between the highest point and the lowest is little more than 3/4 of an inch. Over a distance of roughly 2.5 football fields, the variation is no wider than 2 fingers. The error is about 0.009%. That figure existed before Grok began its analysis. It came from structural surveys. The system merely placed the width of the base beside the change in elevation and calculated the ratio. Imagine a sheet of glass as wide as a city block. From one edge to the other, its highest and lowest points differ by less than the width of 2 fingers. Now, replace that glass with stone. Not one continuous slab, but a surface prepared by cutting into natural bedrock, filling gaps, and setting millions of separate blocks upon it. Some weigh several tons. Some, inside the structure, weigh dozens of tons. Every error in the foundation travels upward through the courses above. A low corner, a tilted edge, or a sunken point does not vanish when the next layer is placed. The error follows the monument all the way to the top. The builders had to establish a level plane across more than 755 feet before a mass of roughly 6 million tons was placed upon it. According to the accepted record, they had water, wood, rope, and the naked eye. One commonly proposed method involves digging shallow channels around the construction area and filling them with water. The water surface provides a horizontal reference. Workers could mark the height, drain the channels, then cut the remaining stone to the same level. Such a method can create a flat plane, but the worksite was not a sealed room. It stood in the open on the Giza plateau. Water evaporates in desert heat. Wind disturbs the surface. Soil absorbs moisture. Channel walls can leak. Sunlight creates temperature differences from one area to another. Each measurement must be transferred from water to stone with ropes, stakes, and carved marks. A small error at one point can be carried into the next. Across hundreds of feet, those errors can accumulate. Rope does not keep a constant length either. It shrinks when dry, stretches when damp, and sags beneath its own weight. A wooden square changes with heat and humidity. A reference line wears away as thousands of people cross the site, yet the base still varies by little more than 3/4 of an inch. Grok was asked to assess whether this result could be achieved with the tools attributed to the age of Khufu. It did not call the feat impossible. It concluded that such a result would be extraordinarily difficult to achieve and dangerously easy to lose if the measurement, transfer of reference points, or cutting of the stone went wrong at any stage. The tolerance was then compared with modern construction standards. Many structures built today do not require a foundation hundreds of feet wide to be level within 0.009%. A floor or foundation slab can vary by several inches while the building continues to function. The frame still stands, the elevators still operate. The people inside never notice the difference. Engineers define tolerances according to a structure's purpose. Greater precision requires more measurements, more time, more equipment, and more money. When a smaller error brings no practical benefit, there is no practical reason to keep reducing it. The foundation at Giza is far more precise than a massive stone monument requires in order to remain standing. A tomb does not need a base level to 0.009%. Rituals conducted around the monument could not reveal a variation of 3/4 of an inch across 755 feet. A person standing at the foot of the pyramid could not see it. The king buried inside could not use it. Yet the builders maintained that degree of level across all 4 sides. Every added measure of precision carried a cost. Stone had to be measured again. High points had to be cut down. Low areas had to be corrected. Reference marks had to be checked from several directions. Finished work might have to be done again if it failed to match the rest. All of this occurred before the first course of stone concealed the surface. As construction continued, most of that precision disappeared from view. No inscription explains the standard they were pursuing. No precision surveying instrument has been found at the site. No surviving plan records the figure 0.009%. Only the stone surface remains. Grok retained 2 possibilities. Either the builders used a method so refined that this precision arose naturally from the process, or that precision was itself a target they deliberately pursued. The system did not choose between them. It stored the first measurement, then moved to evidence that did not lie beneath the pyramid. The next clue waits on the horizon. The Great Pyramid does not merely rest on an almost perfectly level base. The entire structure is oriented toward the 4 cardinal directions. Its sides face north, south, east, and west. These are not rough compass bearings. They align with true north, true south, true east, and true west. The northern side deviates by only about 3 minutes of arc. 1 degree contains 60 minutes of arc. A complete circle contains 360 degrees, or 21,600 minutes of arc. Across the entire circle of the horizon, the side of the pyramid misses true north by roughly 3 parts out of 21,600. The error is too small for the naked eye to detect. A person standing along the pyramid's edge would never see it. No ritual at its base could depend on so slight a difference. Only when surveyors use instruments capable of measuring angles does the deviation become a number. True north is not the direction shown by a compass needle. A compass points toward magnetic north, a position that continually moves as Earth's magnetic field changes. It does not coincide with the geographic North Pole, and it cannot provide a fixed reference across thousands of years. True north is defined by the planet's axis of rotation. No marker in the desert points toward it. No mountain stands in exactly the required position. A surveyor must find it in the sky. The stars move through the night. They rise, sweep in arcs, and sink below the horizon. Yet their motion turns around an almost motionless center, the point toward which Earth's rotational axis is aimed. To determine true north, observers must follow the stars, locate the center of their circles, then transfer that invisible point in the heavens to a straight line on the ground. That line must then extend for more than 755 feet. It must be copied onto the opposite side. 2 perpendicular lines must establish east and west. 4 corners must meet. 4 sides must close into a square. Every error in the first step spreads across the entire plan. If the north to south line is wrong, the remaining sides are wrong as well. If one corner is not square, the final side will not close in the correct place. The builders accomplished this across a foundation covering more than 13 acres. They had no satellite positioning system, no optical theodolite, no precise clock for recording the moment a star crossed the meridian, no telescope for fixing a point of light in the sky. According to the surviving record, they had plumb lines, stretched cords, wooden rulers, and the ability to observe the heavens with the naked eye. Researchers have proposed several possible methods. Surveyors might have watched a star rise and set, marked both positions on the horizon, then divided the angle between them. They might have tracked the shadow of a vertical post through the day, marked 2 points where the shadow reached the same length, then used them to establish an east to west line. They might also have observed 2 stars on opposite sides of the celestial pole, waited until the stars formed a vertical line, then carried that alignment down to the ground with a plumb line. Each method can produce a reference direction, but the result still depends on the timing of the observation, the evenness of the horizon, the stability of the instrument, and the ability to transfer a point from the sky onto bedrock. A post that is not perfectly vertical alters the path of its shadow. A plumb line moving in the wind makes the reference point wander. A star observed too early or too late shifts the line. A small error over a short distance grows when the line extends across hundreds of feet. Yet the northern side remains only about 3 minutes of arc from true north. Grok then compared that measurement with the structure's assigned purpose. A tomb can face roughly north. A temple can follow the movement of the sun or a star with religious significance. A ceremonial structure can face a region of the sky without maintaining a tolerance of only a few minutes of arc. Those attending a ritual could not distinguish an edge that missed true north by 3 minutes of arc from one that missed by half a degree. Both would look identical from the ground. But the builders did not stop at an approximation. They aligned the four sides of a stone mass weighing millions of tons with the cardinal directions more precisely than the human eye can perceive. That precision does not exist at a single point. It runs along all four sides. It had to remain intact while the foundation was prepared. It had to be preserved as each course of stone was placed. The level base and the orientation were not separate problems. A reference line has meaning only when the site has been leveled accurately. A sloping surface makes plumb lines, right angles, and the transfer of reference points between sides more difficult. Before the monument could rise, the builders had to solve both level and direction. Two independent measurements stood side by side. A variation of little more than 3/4 of an inch across 755 feet, a deviation of about 3 minutes of arc from true north. One number lies in the ground, the other lies in the way the entire structure turns toward the axis of the planet. Grok assigned no name to the method that produced them. It identified no particular instrument. The system retained only the result. The base is more precise than structural need demands. The orientation is more precise than observation or ritual requires. Then it left the bedrock and the horizon behind. It took the perimeter of the four sides, placed that figure beside the pyramid's original height, and performed a division. A circle appeared inside a structure with no circular face. The Great Pyramid is made of straight lines. Its base is a square. Its four faces are triangles. Its edges run directly from the foundation to the summit. No circle was built into the exterior. Yet, when Grok divided the perimeter of the base by the original height, a familiar number emerged. The base perimeter is approximately equal to 2 times pi multiplied by the height. Pi begins with 3.1415 and continues without end. It describes the relationship between the circumference and diameter of a circle. If the height of the pyramid is treated as a radius, the perimeter of the base is nearly equal to the circumference of a circle with that radius. A circle lies hidden in the proportions of a square. The match is more than a rough approximation. The stated error in this comparison is only about 0.05%. Grok did not treat the appearance of pi as independent proof. It first tested the conventional explanation. One theory suggests that the Egyptians may have measured horizontal distance by rolling a drum or wheel. Each revolution covers a distance equal to the circumference of the round object. Vertical distance could be defined with cubit units placed one after another. If a building were measured in these two different ways, pi might enter its proportions without anyone writing or naming the number. The geometry of the drum would carry the relationship between a circle's circumference and diameter into the measurement. The builders would not need to know pi as 3.1415. They would only need to roll a round object. This explanation offers a path by which pi could appear unintentionally. For a single ratio between perimeter and height, it cannot be dismissed. Grok continued testing other dimensions of the monument. The relationship involving pi did not appear only once. It recurred in other geometric ratios, in places that did not all depend on horizontal measurement with a drum. One measuring process might leave one trace. But for the same ratio to appear in several independent relationships, other dimensions must also be chosen so that the trace remains. The system placed these appearances beside one another and considered whether all of them could arise from random variation. One instance could be a byproduct of a tool. Several instances require the same byproduct to recur in exactly the necessary places. Grok recorded the repetition and moved to the next number. This one could not be produced by rolling a drum. It was phi, the golden ratio. Phi begins with 1.618 and continues without end. It appears in certain geometric forms, in the branching of plants, in the arrangement of seeds within flowers, and in growth spirals found in nature. According to the surviving written record, Greek geometers described this ratio around 2,000 years after the Great Pyramid was built. That span is almost as long as the distance between the modern world and the Roman Empire. No mathematical text from the age of Khufu explains phi. No symbol for the ratio 1.618 has been found on a pyramid plan. No such plan survives. But the ratio appears in the monument's dimensions. Grok found it in the relationship between the height and half the length of the base. It appears in the sloping distance from the foot of a triangular face to the summit. It appears in the slope of the faces. It appears again in ratios derived from the interior geometry. The system counted at least 7 separate dimensional relationships that produce values close to phi. These 7 locations do not depend on the same measuring wheel. The 7 ratios lie in the height, the base, the sloping faces, and the interior structures. To produce phi in geometry, a series of dimensions must relate to one another in a particular proportion. Change the height while keeping the base fixed, and the ratio disappears. Change the angle of a face, and it disappears. Change the sloping length, and the result changes again. The dimensions must converge upon a single form. A drum can carry pi into a horizontal distance because every revolution contains the geometry of a circle. A drum does not contain phi. A measuring rod laid end to end does not create phi either. A plumb line supplies only a vertical direction. A water channel supplies only a level plane. None of these tools automatically creates a ratio of 1.618 between the height, the base, and the slope. If phi appeared in only one place, measurement error and the selection of dimensions could create an approximate result. When it appears in 7 relationships, each occurrence must be considered together with the other 6. Grok placed pi beside phi. Pi lies in the relationship between perimeter and height. Phi lies in the relationship among height, base, and sloping length. Both are irrational numbers. Their decimal expansions never end. Neither can be represented exactly by a finite fraction. The builders left no symbols reading 3.1415 or 1.618 on the walls. They left a height. They left 4 sides. They left an angle of slope. They left chambers and corridors within the structure. The numbers appear only when those dimensions are measured and compared. A person could stand before the pyramid for a lifetime and never see pi. A person could walk through its passages and never see phi. They were not written for the eye to read. They reside in proportion. After 4,500 years, the outer casing stones have been removed. The capstone is gone. Parts of the surface have eroded or been destroyed. Yet the original dimensions can still be reconstructed from what remains. The perimeter is compared with the height. The sloping length is compared with half the base. Pi and phi return. Grok did not name the person who selected those proportions. It recorded only that the drum explanation may account for one part of the evidence, but not the entire pattern. The foundation produced the first number. True north produced the second. Pi and phi formed a network of ratios running through the geometry of the monument. Then Grok took the pyramid's original height and multiplied it by 43,200. The result no longer belonged only to the Giza plateau. The original height of the Great Pyramid is estimated at about 481 feet. Grok multiplied that figure by 43,200. The result approximates Earth's polar radius, the distance from the center of the planet to either pole. The system then took the perimeter of the pyramid's base, the combined length of all 4 sides, and multiplied it by the same factor of 43,200. The result approximates Earth's circumference around the equator. 2 dimensions of a building, 2 dimensions of a planet. The same multiplier. The height corresponds to the polar radius. The perimeter of the base corresponds to the equatorial circumference. If these relationships are read in that way, the Great Pyramid becomes a scale model of Earth at a ratio of 1 to 43,200. The dimensions of the planet are not carved into the stone as words. They are folded into the height and base of the monument. Nor is the number 43,200 separate from the way humans measure time. 12 hours contain 43,200 seconds. The number links half of Earth's daily rotation with the ratio between the pyramid and the planet on which it stands. One dimension rises vertically, the other travels around the base. A single number expands both to a planetary scale. To create that relationship intentionally, a designer would need 2 different values, Earth's polar radius and Earth's equatorial circumference. Those values cannot be derived from a single measurement. Earth is not a perfect sphere. The planet bulges slightly at the equator and is flatter at the poles. The distance from the center to a pole is not the same as the distance from the center to the equator. To place both dimensions within one monument, the designer would have to address the shape of the planet through multiple measurements. The values would then have to be reduced by the same factor. The height would have to be chosen. The lengths of the four sides would have to be chosen. The slope of the faces would have to connect those dimensions while preserving the pyramid's form. But that slope also carries pi and phi. The base must remain a square. The four sides must still face the cardinal directions. The entire foundation must still maintain an elevation difference of little more than 3/4 of an inch. Every layer of evidence lies within the same structure. Change the height to break the ratio of 1 to 43,200, and the relationship with the perimeter changes as well. Change the length of the base, and the angle of the faces changes. When that angle changes, the ratios involving pi and phi no longer remain intact. The numbers do not reside in parts that can move independently. They are locked into the same geometry. Grok placed the entire series of measurements side by side. A foundation more than 755 feet long on each side, with an elevation difference of little more than 3/4 of an inch. A northern edge about 3 minutes of arc from true north. A base perimeter related to the height through pi. A height, half base, and sloping length that create relationships close to phi. A height and perimeter that, when multiplied by 43,200, return 2 dimensions of Earth. Each individual observation has a counterargument. The level foundation might result from water channels and patient surveying. True north might be established by observing the stars. Pi might enter the structure through a measuring drum. Phi might arise from the chosen dimensions or from the natural geometry of a pyramid with a particular slope. The relationship of 1 to 43,200 might result from taking approximate measurements and searching for a convenient factor. Grok tested each explanation separately. Then it placed them all back inside the same monument. Water channels had to create the foundation. The stars had to establish direction. A drum had to create pi. Another set of proportions had to create phi. A factor connected with time had to link the height and base to the dimensions of Earth. 5 separate processes had to converge inside a single stone monument built during the 3rd millennium BC. All had to appear within the limits of the same base, the same height, and the same slope. The system did not dismiss coincidence. It actively searched for it. A ratio can emerge from a measuring method. A direction can be achieved through prolonged observation. A surface can be leveled with water. Multiplication can bring almost any pair of dimensions close to a familiar result if enough factors are tested. But in this case, the same factor applies to 2 different measurements. The height is not multiplied by one number, while the perimeter is multiplied by another. Both use 43,200. The first result points toward the polar radius. The second points toward the equatorial circumference. And 43,200 is also the number of seconds in 12 hours under the modern system of timekeeping. 3 layers of relationship overlap: the monument, the planet, the rotation of the planet through time. Grok found no Egyptian text stating that this was the purpose of the design. No inscription calls the pyramid a model of Earth. No record from the reign of Khufu gives the polar radius or the equatorial circumference. Surviving papyri describe the transport of stone. Red inscriptions preserve the names of work crews. The settlement reveals who lived at the site. But no document explains the chain of proportions contained in the finished structure. The archaeological evidence and the measurement evidence do not contradict each other. One records the people who were present. The other records the standard the monument achieved. The gap lies between these 2 groups of evidence. Someone quarried the stone. Someone transported it. Someone set the blocks into place. Yet, before the first block was laid, the monument's dimensions had to be defined. The height, the base, the slope, the orientation, the level plane. The labor crews could execute a plan. That plan does not appear in the surviving record. When Grok removed the answers that the data could not confirm, 4 possibilities remained on the table. Grok did not name a civilization. It did not assign a different date. It did not conclude that visitors from another world built the Great Pyramid, nor did it point toward a lost continent and declare its inhabitants the architects. The system returned to the traditional explanation. Pharaoh Khufu, about 20 years of construction, organized work crews, copper chisels, stone hammers, wooden sledges, ropes, levers, and ramps. The archaeological evidence remained in place. Egyptians lived at the worksite. They transported stone. They left records, tool marks, and the names of their crews. Grok did not judge this explanation to be false. It judged it to be incomplete. The evidence explains the workforce. It does not yet explain the full standard of the monument. The base varies by little more than 3/4 of an inch across 755 feet. The four sides align with the cardinal directions. The deviation from true north is only about 3 minutes of arc. Pi appears in the relationship between perimeter and height. Phi appears in several geometric ratios. When multiplied by 43,200, the height and base perimeter point toward two different dimensions of Earth. Granite blocks weighing dozens of tons were raised to high positions within the structure. Stone beams spanning the chambers distribute the load of millions of tons of material above. Those chambers still survive after roughly 4,500 years. Beyond the pyramid, the Sphinx bears weathering patterns that some researchers associate with prolonged rainfall. Today, the Giza Plateau lies in a desert. Periods of greater rainfall push the proposed date of that weathering farther back than the age of the pharaohs. This claim remains disputed. The marks also remain on the stone. When the evidence is placed side by side, the gap does not appear in the question of who pulled the blocks. It appears before the pulling began. Who determined the dimensions? Who chose the slope? Who set the standard for the foundation? Who found true north? Who decided that an error invisible to the eye still had to be corrected? Who created the plan that thousands of workers later carried out? No plan survives, no precision instrument survives, no text explains the proportions that remain. Only the monument remains. From that absence, 4 possibilities emerge. The first is a lost Egyptian technology. Under this possibility, the Egyptians of Khufu's age possessed methods of surveying, stone cutting, and construction management more sophisticated than anything preserved in the archaeological record. These methods may have passed orally among specialized groups of craftspeople. They may have been kept secret, used for a brief period, then lost when a dynasty, religion, or training system changed. The builders would still be Egyptian. The gap would lie in knowledge that disappeared. The second possibility is knowledge inherited from an older culture. Under this scenario, the crews of Khufu built or completed the monument using a system of measurement that existed before their dynasty. The Egyptians may have adopted ratios, astronomical methods, and engineering standards without preserving their original source. The name of Khufu would still appear. His workers would still have moved the stone. But the plan might have begun before them. The third possibility is the trace of a civilization that existed near the end of the Ice Age. Under this scenario, an advanced culture arose before the civilizations preserved in recorded history. A catastrophe, or a series of climate changes, erased most of its physical remains. Survivors carried mathematics, astronomy, and surveying techniques into communities that formed later. The knowledge endured. The names of those who created it vanished. The fourth possibility is a source that was not human. Grok did not select this possibility. It retained it only because the evidence provided was not enough to exclude it completely. No object of extraterrestrial origin has been found at Giza. No Egyptian text describes a builder arriving from another world. This possibility has no direct supporting evidence. It exists at the outer edge of the gap, where the remaining explanations do not yet encompass every measurement. The 4 possibilities do not carry equal weight, nor do they require the same number of assumptions. A lost technology requires only that the surviving record be incomplete. An older culture requires an unidentified line of transmitted knowledge. An Ice Age civilization requires an entire missing chapter of history. A source beyond humanity requires evidence that has never been found. Grok was not asked to choose the most compelling story. It was asked to consider what the numbers permit. The numbers do not preserve the builder's name. They preserve only the trace of the standard that was used. And the remaining question does not belong to Giza alone. It lies in the way the modern world views the past. History is often told as a steady ascent. Tools improve. Mathematics becomes more precise. Astronomy grows deeper. Each generation knows more than the one before. The Great Pyramid stands near the beginning of the record of civilization, not the end. Its foundation achieved a tolerance of 0.009%. Its sides faced the axis of the planet. Its geometry carried pi and phi. its proportions expanded toward the dimensions of Earth. Yet many structures built later did not repeat this same combination. If knowledge always travels in a straight line, the stones of Giza stand in the wrong place on that line. If the monument belongs entirely to the age of Khufu, then the missing element is the method. If the method came from before Khufu, then the missing element is history. And if neither possibility is enough to close the gap, the other two remain on the table: a lost Egyptian technology, knowledge inherited from an older culture, an Ice Age civilization erased from history, or a source that never belonged to humanity. Which possibility would you choose, and what evidence are you prepared to use in its defense?